All right, ladies and gentlemen, these are going to be your density through displacement notes. As you listen through and go through this video, I expect you to follow along and you're going to complete these notes alongside with me. So as I do it, you can pause the video and go do the same thing onto your notes so that you get the information that you need. Displacement can be a very, very difficult thing if you're not paying attention to the details, okay? So let's go ahead and get started. Density through displacement. When an object is irregularly shaped and the length, width, and height cannot be measured with a ruler, then the water displacement method is used to calculate the volume, because you need volume to find density. A graduated cylinder is used to measure a given volume of water. The object is then added to the cylinder and the water level rises. The initial volume is subtracted from the new volume to give you the volume of the object itself. So if we look over here, I've got my little T-Rex here, right? Here's my first graduated cylinder with the T-Rex out. So I'm first going to locate what the initial volume is before I put anything in it. And I'm going to do that by reading the graduated cylinder. The big lines tells me the big numbers. And then the little lines, this one's divided by 2. So it'd be 4.2, 4, 6, 8, and then 5, okay? So I'm going to locate the bottom of the water level. This little curved water, almost like a bubble, is called a meniscus. So when you are measuring, you do not measure the top sides, okay? Because if that's the case, it'd be at 5. That's incorrect. You measure the bottom, almost like the bowl, and you want to measure the bottom of the bowl, okay? So this bottom of the bowl is at 4.2468. Then I'm going to put my T-Rex in. When I put my little T-Rex in, the water level goes up. So I'm going to measure the new water level. It's definitely above 4.8. So we're at 5.246 because I'm going to the bottom. So before it was 4.8, after it was 5.6. So if I come down here, I want to find the total volume of my T-Rex. I'm going to take my final volume of 5.6 and I'm going to subtract my initial volume, which was 4.8, and that leaves me with 0.8 milliliters. That's the volume of my dinosaur. Let's go to the next slide. So on the next slide, calculating density, the mass of an element, this is an example. The mass of an element sample was calculated to be 18 grams. I know the mass. A graduated cylinder was filled to the 70 milliliter mark, and then the rock was placed in the cylinder. Use the information below to determine the volume, density, and identity of the unknown element. Okay, so this is the new water level after, because see, my rock's already in there. They told me I started at 70. So if I was to look, there's my large 9, and my large 9 is 70 and 80. And how many little lines do I have in between? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this tells me it'd be 71, 72, 73. So I'm going to count all the way up, and this is 76. Okay, so that's my new water level. So on the next slide, they give me the mass, they give me the volume. It's telling me to find my final volume. So my final volume will be 76 milliliters. Now I have to find the total volume of my mineral. So I'm going to pull up my calculator, and I'm going to take 76, and I'm going to subtract 70 from it, and I will have 6. So 6 milliliters, that's the volume. Now I have mass, and I have volume. Now I can calculate for density. So I put this little sticky note over here in case you wanted a reminder of what the calculation for density is, but also if you wanted to jot down any notes, okay? So if I'm going to calculate density, I'm going to set up my problem. So density equals mass. My mass is 18 grams. 18 grams divided by my volume is 6, so 6 milliliters. So this will tell me that my density is, some of you might be able to do some of these in your head, and that's okay. I'm going to use a calculator. So 18 divided by 6, 3. So the density of my mineral is 3 grams per milliliter. Once I know my density, I can come, well, let's plug it in. So 3 grams per milliliter. So once I know the density, I can compare it to this chart I have here. And I'm just going to locate where 3 grams is, and it'll tell me what my mineral is. So here's 3 grams, 3 grams. So my mineral is aluminum, and that is what we type into the box. Okay. Final slide. What tool can be used to measure the length, width, and height of an object with a regular shape? So you're going to go back up to this slide and reread it. And it does say within this first paragraph what tool you use if you're trying to locate the item of a regular shape. Okay? Displacement is for irregular. What is the property that describes the amount of space an object takes? And describe how you would measure the volume of an irregular shaped object such as a ring. So I want you to write your responses here. We're not going to write those responses together. I want to make sure that you're understanding what you have read and learned today. Once you're completed with these notes, you can submit them, and then you're going to go complete a Ed puzzle on density displacement method so that I can understand and catch any misconceptions that you may have. Okay, thanks guys. I really appreciate it, and have a great day.